We've all been there, right? You're writing code and you realize you're typing the same exact lines over and over again. It feels clunky, it's a nightmare to fix if you find a bug, and it just feels messy. Well, there's a powerful, elegant way to fix this, built right into Python. And we're going to talk all about it today: functions. You know, this whole idea really boils down to one of the most important principles in all of programming: don't repeat yourself, or as we call it, dry. Because every time you copy and paste, you're setting a trap for your future self. Need to make one tiny change? Now you have to find every single copy and change it. This isn't just about being lazy, it's about being smart. And hey, take a look at this. It's the perfect example. On the left, we're wishing someone a happy birthday by just copying and pasting the song. It works, sure, but yikes, it's clunky. Now look at the right. We wrote the song just once, wrapped it up in a neat little function, and now we just call it when we need it. It's clean, it's readable, and it's perfectly DRY. That right there, that's the magic we're talking about. All right, so here's the game plan for today. We're going to start with the why. Why even bother with functions? Then we'll dissect one piece by piece. We'll see how to pass information in and how to get results out. Then, for fun, we'll look at a couple of functions with some real superpowers. And finally, we'll wrap up with the little things that'll help you write functions like a total pro. So we know that repeating code is just asking for trouble. It's messy, it's fragile, and it's a headache to maintain. Now, let's start building our defense against it.
So, what's the solution? Well, it's the function itself. Let's put one under the microscope and see what it's made of.
At its core, a function is just a named block of code that you can use over and over. Think of it like a recipe. To write this recipe, you start with the keyword def, which just means I'm defining a function. Then you give it a clear descriptive name. After that, you add a pair of parentheses, and you finish the line with a colon. Anything indented underneath that line is part of your function. It's that simple. Okay, so you've defined your function. You've built this awesome little code machine. How do you turn it on? You call it. You just type its name followed by those parentheses. I love this analogy here. Think of the parentheses like a telephone. You're literally making a call to your code, saying, hey you, it's your turn. Do your thing. Now, this is where functions go from being useful to being incredibly powerful. We're going to see how to make them dynamic by passing information into them so they can do different things each time we call them. Okay, first things first, let's clear up two words that trip up everybody: parameter and argument. It's easy, I promise. A parameter is the placeholder variable you create when you define the function. See the name inside the parentheses? That's a parameter. It's like a labeled empty parking spot. An argument is the actual value, the real data, like Alice, that you give the function when you call it. It's the car that parks in the spot. So the argument fills the parameter. The most basic way to send arguments is by position. It's exactly what it sounds like. The first value you send goes into the first parameter, the second value goes into the second, and so on. But you gotta be careful, because the order is absolutely critical here. Get it wrong, and you might be telling your program that your name is 20 and your age is bro. But what if you hate having to remember the exact order? Well, that's what keyword arguments are for. By using the parameter name like a label, age equals 30, name equals John, you can pass them in whatever order you want. It doesn't matter anymore. Plus, it makes your code so much easier to read later on. You can also set up a plan B for your parameters. This is called a default argument. Here, we're saying that if someone calls the greet function without giving it a name, just use the name guest by default. It makes your functions way more flexible, because now that argument is totally optional. Okay, so this is all great when you know exactly how many arguments you need, but what if you don't? What if you want to write a function that adds numbers together, but you don't know if the user will give you 2 numbers, or 5, or 100? How do you handle that? Well, Python has this amazing, almost magical solution. It's called arbitrary arguments. If you put a little star in front of a parameter, like args, it will scoop up any and all positional arguments you throw at it and pack them into a nice, neat tuple. And if you use 2 stars, like KW args, it does the same thing for keyword arguments, putting them into a dictionary. This is the secret to ultimate flexibility. So far, our functions have just been, doing things. mostly printing to the screen. But a lot of the time, what you really want is for a function to figure something out and then hand you back the answer. This is the payoff. And the way we get that answer is with the return statement. The moment Python hits a return line, the function stops dead in its tracks. It's over. And it sends whatever value you specified right back to the spot where you called it. Then you can catch that value and store it in a variable, just like we're doing here with result. And check this out. This is a super cool, very Pythonic feature. You're not just limited to returning one thing. If you want to return multiple values, just separate them with a comma. Python is smart enough to automatically bundle them all up into a single tuple for you. It's like getting a little gift-wrapped package with all your results inside. So convenient. All right, you've totally got the fundamentals down. Now let's take a quick peek at a couple of more advanced function types. These are the ones with what I like to call superpowers. Okay, look at the left, a normal function. We've seen that. Now look at the right. That's a Lambda function. Think of it as a small, anonymous, disposable function. Use the Lambda keyword, and you can only have one single expression. They are perfect for those little one-off tasks where defining a whole formal def function would just feel like overkill. Now, let's talk about return versus yield. A return statement is like a vending machine. You put your coin in, you get one item back, and the transaction is done. Over. The yield keyword, though, that creates something called a generator. It's more like a Pez dispenser. It gives you one value, but then it just pauses, remembering exactly where it was. When you ask for the next one, it picks up right where it left off. This is unbelievably efficient for working with huge streams of data because it only creates one value at a time. So knowing the rules of syntax is one thing, but writing truly great professional functions, that's an art. This is about more than just the rules. It's about the philosophy that separates good code from truly great code. I absolutely love this quote. What's it really saying? It's saying that simple is smart, clever is fragile. Your goal shouldn't be to write the most complex, impressive code you can think of. Your goal should be to write the clearest code you can, because someone, and it's probably going to be you, will have to read it and fix it 6 months from now. So, to write code the Pythonic way, here are a few final tips. First, naming. Give your functions names that reveal what they do. Not func1, but calculate_sales tax. Second, docstrings. Document what your function does, what its parameters are, and what it returns. Trust me, your future self will thank you. And finally, a slightly tricky one. Understand how Python passes arguments. It's called pass-by-object reference. The simple takeaway is this. If you pass something simple like a number into a function, the original can't be changed. But if you pass in something complex like a list, the function can actually modify your original list. It's just something to be aware of. So we've gone from a total mess to clean, powerful, reusable code. And I want to leave you with a challenge. The next time you're coding, ask yourself this. Yeah, my code works, but is it reusable? Is it organized? I want you to look at a project you're working on, find a piece of code you've copied and pasted, and ask yourself, what are you going to refactor into a function first?